Hi, welcome to my video on proofs using definition of a parallelogram. But before we start this video on using definition of parallelogram in proofs, just a reminder that you should have done the unit on congruent triangles prior to looking at these videos in this unit. Very important to know how to prove triangles congruent by different methods, and that unit should be done before this one. Anyway, let's start. The definition of a parallelogram. Notice parallelogram, I have two strokes, an O and a GM. That's the abbreviation that I'm going to use for parallelogram instead of writing this long word out. So a parallelogram is a quadrilateral with two pairs of opposite sides parallel. So notice parallel, parallel, two pairs of opposite sides parallel. So we have P, Q, R, S. If this is a parallelogram, then PQ is parallel to SR. PQ is parallel to SR, marked with one strokes, and PS is parallel to QR. PS is parallel to QR with two strokes. And note, we go around in order, P, Q, R, S, in order from P to Q, Q to R, to S to P. So, in proofs, if we're given that A, B, C, D is a parallelogram, then the first statement is A, B, C, D is a parallelogram given. The second step is that AB is parallel to DC, AB is parallel to DC, and AD is parallel to BC. And that's the definition of a parallelogram, because a parallelogram has opposite sides parallel. So let's look at this definition with the parallel lines. And what happens with parallel lines? Well, we get what we call incongruent triangles. We have the PLT, alternate interior angles, corresponding angles equal, etc., etc. So here we go. Let's do some examples. A, given xy equals xt. So xy is equal to xt. And we're given that Vxyw is a parallelogram. Vxyw is a parallelogram. So we're going to take this given and put it together to prove that angle 3 equals angle 2. So angle 3 is right here, VWT, and angle 2 is right here, XTY. So I need to get 3 equals 2. So how are we going to do it? Well, we don't have any congruent triangles, so let's see. If we have XY equal to XT, what's that going to do? So that leads us, if these two sides are equal, that means these two angles are equal. So now I can have these two angles equal. So how do I relate? I can get 1 equals 2. I need 3 equals 2. So that means I must come up with 1 equals 2 in order to do a transitive property. So here we go. XY is equal to XT. So that's number 1. So that's a given. And as a result of that given, I have angle 1 equals angle 2. And the reason for that is what I call ITT, Isosceles triangle theorem. Again, this comes out of the congruent triangle unit. Very important to look at the congruent triangles unit. So we have 1 equals 2. Now, if I have 1 equals 2, I need 3 is equal to 2, so I have to get 1 equals 3. So, parallelogram. What does the parallelogram give me? Vxyw is the parallelogram. And how is that going to help me? That's a given. Well, the parallelogram has parallel sides. So, that means that if I want to get 1 equals 3, I have to say that VW is parallel to XY. And the reason for that is the definition of a parallelogram. So we have parallelogram, we have opposite sides parallel. So these parallel lines are going to give me, because these two lines are parallel to each other, WY is a transversal. So that means that angle 3 is equal to angle 2. And notice, again, congruent triangle chapter on parallel lines, we have, these are corresponding angles equal. So this is how I did it. I said PLT, parallel line theorem, and I write down corresponding angles equal. This is abbreviation instead of writing out the long statement. And as a result, I now have 1 equals 2, 3 equals 2, so that means angle 1 equals angle 3, and the reason is transitive property of equality. And the proof is done. So proofs are, you have to line up the proofs in your head, get it formatted, and then you write it out. If you start to write it out without looking through the proof first, then you might have it all written down and not be able to do it correctly. Let's do B as an example. Again, we have this figure, and we're given that ABTE is a parallelogram. ABTE is a parallelogram. So this is a parallelogram. And because we have a parallelogram, I know we have opposite sides parallel. We're going to have probably parallel lines. We're going to have equal angles needed in a proof. We also is given that FE is equal to CB. So FE, this right here, is equal to CB. So how are we going to prove that BE bisects FC? So if BE bisects FE, that means that OF is equal to OC. So we have to get OF equal to OC in order to prove that this is a bisector. Because if it makes two equal segments here, that means this is going to act as a bisector. So that means we have to get a pair of congruent triangles. That's why we did the unit on congruent triangles first. So how do we get congruent triangles? Well, we got these two sides given, so we need some angles. So we could have this angle right here, 1 equals to 2. We could have this angle here, 3 is equal to 4. Why? Because AE is parallel to BT. Because these two lines are parallel, 1 and 2 are alternate interior, and 3 and 4 are alternate interiors. So that gives us these angles. As a result of 3 equals 4 and 2 equals 1, then these triangle OFE and OCB are congruent by angle, side, angle. And because the triangles are congruent, then I can get OF equal to OC, or what we call CPCTC, corresponding parts of congruent triangles congruent, and that leaves us with the bisector. So here we go. So we're given that A, B, T, E is a parallelogram. Number 1, that's the given. So notice I did the proof first in my head, and now I'm going to put it all together. So here we go. Number 2 is that AE is parallel to BT, and that's the definition of a parallelogram, which means the opposite sides are parallel. And as a result of that, because these lines are parallel, I have angle 1 equals angle 2. Angle 2 equals angle 1. I also have angle 3 equals angle 4. And the reason is PLT, parallel line theorem. But these are alternate interior angles equal. alternate interior. And number 4, now I have 2 angles, I need a side. So FE is equal to CB. FE is equal to CB given. And as a result, I have the triangle. And I'm going to go OFE. OFE is congruent. And OCB. OCB. And it's an angle, side, angle. Angle, side, angle congruency. And as a result of these triangles being congruent, I have OF is equal to OC, and that's CPCTC. Corresponding parts of congruent triangles are congruent. And number 7, because these 2 segments are equal, that means that BE bisects OF. Oh, sorry, OC. I said, oh, sorry, better be careful. BE bisects FC. These 2 segments, OF equals OC, so BE is bisecting FC. And that's the definition of segment bisector. Again, stemming from the congruent triangle unit that we did earlier. Okay, let's continue. Again, we're doing proofs pertaining to the sides parallel. Later on, you're going to do proofs with other methods in relation to the parallelogram. But right now, we're dealing with the sides parallel. Okay, practice means that you can now pause the video and see if you can do this proof. And then this one and this one. Work them out. See if you can do them. And give yourself time to work it out. And then press play to see if you're right. Here we go. We have this figure. So we look it over. And angle 1 equals angle 2. So this angle 1 right here, angle 1 right here is equal to angle 2. We have STVW. STVW is a parallelogram. STVW is a parallelogram. So I have to, how am I going to get that SWF is an isosceles? And I should say isosceles, well, let's put in triangle. We have an isosceles triangle. So when I have an isosceles triangle, I need 2 sides equal. And there's no congruent triangles here, so probably I have to get it based on getting a pair of angles equal. And because if these 2 sides are equal, notice I'm dealing with 1 and 2, so let's see if we can get 1 and 3 equal. If I can get 1 and 3 equal, that means that these 2 sides are going to be equal, and that means this is going to be isosceles. So I have to get, I already have 1 equals 2. Okay, so I have 1 equals 2 given. Now, can I get 2 equals 3? Well, 2 is going to be equal to 3. Well, ST is parallel to WV, and that's, oh, I forgot to put, oh, STVW is a parallelogram given. Because before I say parallel lines, I have to say that I have a parallelogram. Now I can say definition of a parallelogram. So you have to ask your teacher if you can put all the givens in the first statement, or do you have to put them in one at a time when you're doing your proof. Notice I got the 2 givens in here. And because I have the parallelogram, I can say these are parallel by definition. And as a result of those 2 lines being parallel, that means angle 2 is equal to angle 3. And notice that this angle here, this is a transversal, these are the parallel lines, so it's forming that Z. So that means that this is a PLT, parallel line theorem, and these two angles are alternate interior angles are equal, PLT. Parallel lines give you alternate interior angles equal. And because we have 1 equals 2 and 2 equals 3, that means angle 1 is equal to angle 3, and we'll just say transitive property. Transitive property, and we know, or ask your teacher again, transitive property of equality. Because we have 1 equals 2, that means that I have SW is equal to SF. And that's what we call converse of ITT. That is, if you have two angles in a triangle equal, then the sides opposite those two angles are equal. That's the converse of the ITT. And again, that's in the unit on congruent triangles. And number 6, because we have these two sides equal, that means that triangle SWF is an isosceles triangle. And reason is definition of an isosceles triangle. A triangle is isosceles if you have two sides equal. And that takes us through that proof. And here comes another one. Now, we have a diagram a little bit more triangles here. So we look at the given, look at what we're going to prove. We look at our given, we look at what we're going to prove, and then do a plan of attack. Let's see, we have AR equals BE. AR, which is this one right here, AR equals BE. Okay, what's that going to do? Well, I see that AB is common in that two segments. Now I have PQTV, PQTV is a parallelogram. Because I have a parallelogram, I'm thinking about parallel sides, which will give me angles equal. And when I think about that, angles equal is going to help me to have or produce congruent triangles. Let's see what we have to prove. That EV, this segment right here, is equal to RQ. So if this segment is going to equal to this one, then I might have to prove that the triangle AEV is congruent to BRQ. So I have to get these two triangles right here congruent. And how are we going to do it? Well, we have to get a pair of sides. So I notice that I'm going to, this is common, so I can take that away. And if AR is equal to BE, then I subtract AB out, and I'll get BR equals AE. So I can get these two sides, AE equals BR. Okay, now I can't get any more sides, so I must need two angles. So how am I going to get my angles? Well, I got parallel lines. Let's see. If I have this line parallel to this one, notice I got PQ, so, and I have TV, but PQ is extended out to here, so when I say PQ, I'm also referring to PR. When I say VT, I'm also referring to TE because it's extended. So if these two lines are parallel to each other, then I have this angle E right here equals this angle R. Because these lines are parallel right here, this is a transversal. So these two angles are alternate interior. Now I have these angles equal. Okay, I have this side and this side, AE and BR. I have the angle E equals angle R. Now I need another pair of angles equal and I have my triangles congruent. Well, one way is that I can deal with this angle A. Let's call this angle A1 and call this angle RBQ angle 2, and let's call EAV angle 1. And also, if I can get these two angles equal, then I'll have these triangles congruent by angle, side, angle. Remember, I got an AE, I got this angle E, and if I get angle 1 equals angle 2, I got an ASA. So, I got parallel lines. So 1 is equal to 3. 2 is equal to 3 because of vertically opposite angles. Two lines intersect, the vertically opposite angles are equal. And then 1 equals 3 because PV is parallel to QT. So that means that 1 is equal to 2 by transitive property, and I have my triangles congruent by angle, side, angle. A little bit more to this proof. I made it up to be a little bit more rigorous because proofs sometimes are hard to see. We have to do all the work. We have to make sure. But notice I have a plan. So I will get the triangles congruent, and then I'll say EV is equal to RQ by CPC/DC. So here we go. So let's deal with AR is equal to BE given. Now, number 2 is that AR is equal to RB plus BA, and BE is equal to BA plus AE. And that's what I call, from the congruent triangles, the segment addition postulate. Segment addition. Now, as a result, that means that if AR equals BE, AR is here, BE is here, that means that RB plus BA is equal to BA plus AE. So these two are equal. There they are there. So that means that this right side is equal to this right side. And that's what we call the transitive property. Again, teachers will accept you, again, clear it by just saying transitive property. It's understood of equality. And now I have to, we notice that we got BA on each side. So again, BA equals BA. And this is what we call the reflexive property of equality. Again, that's in the doing proofs on congruent triangles, the properties you had to learn early. And now, because these are equal, we can subtract them. So, notice I got R, see that? That's an R, B there. So that means that R, B is equal to AE. And that's because of the subtraction property of EQALITY. Now we have this one equal to this one. So now we need to get the angles. Again, this proof is a little bit long, but now we have to say we want to get angle E equals angle R. We have to say that PR or PQ is parallel to VT. That's the definition of a parallelogram. And that means that PQ is parallel to VT. That's the same as saying that PR is parallel to ET. And we have angle E equals angle R. And notice they're crossing over. That's a PLT, alternate interior angles equal. And as a result, now we have these two angles equal. We have these two sides equal, A, E, and this angle. We need another angle, so I put these in. So we're going to say that angle 2 equals angle 3, and that's vertically opposite angle theorem. If two lines intersect, AR and QT intersect, then 2 is equal to 3 by vertically opposite angles equal. Now, I have to say that PV is, parallel to, PV is parallel to QT, and that's the definition of parallelogram. And as a result of those being, that's a parallel to this one. This is a transversal, AB, so that means angle 1 equals angle 3, and the reason is a PLT, and that's corresponding angles are equal. Corresponding angles are on the same side to transversal. These two here, angle E and angle R, are on opposite sides, so they're alternate interior. So notice we have 2 equals 3, 1 equals 3, so number 11, so angle 1, make that a 1, equals angle 2. Angle 1 is equal to angle 2 by transitive property. And as a result, we have angle, side, angle. So we have triangle A, E, V, congruent to triangle AEV is BRQ. BRQ, and that's an angle, side angle. Congruency. And as a result of that congruency, we have EV equal to RQ. And the reason, CPCTC. And you can see the proof is, again, all proofs are not going to be easy to do. This one's a little bit longer. There's a little bit more to it, and you had to know your unit on congruent triangles. And let's do the last one. Again, pause your video and see if you can work these out. The more you can do, the more thinking you can do, the better. And we're given this figure, so see the figure? We're given that angle 1 equals angle 2, angle 1 is equal to angle 2. We're given that ABCF is a parallelogram. Okay, parallelogram got opposite sides parallel, and the parallel lines are going to give me equal angles. So let's keep that in mind. We're also given that angle 3 is equal to angle 4. We're also given that HF, this segment, HF is equal to GC, this one. So this segment right here is equal to this segment. And it looks like I want to get AH equal to BG. AH equal to BG. So AH and GB are in the triangle AHF and BGC. So if I can prove these two triangles congruent, I can get AH equals BG CPCTC. So how do I do it? Well, I have one angle. I have angle 3 equals angle 4, so that's the A. I have this side, HF equals GC given. So I got an angle on a side, I need another side. So if I have this side, that would be, if I have this side equals this side, that would be an ASS. I can't have it. If I had BG equal to AH, but that's what I got to prove. So I need an angle. So how do I get an angle? Oh, I got parallel lines. And parallel lines gives me, that's 1, 2, 3, 4. I'm going to name this angle as 4 and name this angle as 5. The parallel lines gives me 2 equals 5 alternate interior across the transversal. It gives me 1 equal to 6 alternate interior. So if 1 is equal to 2, 2 is equal to 5, and 1 is equal to 6, that means 5 is equal to 6 by transitive. More than one transitive. So now we have 3 is equal to 4 given. HF equals GC given. 5 equals 6. We prove it. And that means that these triangles are congruent by AAS. And we have these two segments equal CBCTC. So that's here. That's my plan. So here we go. Let's go with angle 1 equals angle 2 given. Number 2, we got a parallelogram. A, B, C, F is a parallelogram. And I could have put the two givens in one, but I just kept them separate. I could have put the two of them into one. Here we go. I marked this angle as 5. I marked this angle as 6. So I know that the lines are parallel. So I have to say the lines are parallel first. So AB is parallel to FC. And that's the definition of a parallelogram. And as a result of AB parallel to FC, angle 2 is equal to angle 5, and angle 1 is equal to angle 6, CPCTC. So we have 2 equals 5, 1 equals 6 right here. 1 equals 2, there's 1 and 2. So that means angle 5 is equal to angle 6 by transitive property. And again, more than one. Check with your teacher, just transitive or two transitives or what. So now I have 5 equals 6. Now I can say that angle 3 is equal to angle 4. And I can also say that HF is equal to GC given. So if you put 5 equals 6, 3 is equal to 4, and HF is equal to GC, I have the triangles congruent. Triangle A, H, F, you have to make sure you match up the correct letters. AHF, A goes with B, so it's B, G, C, and that's angle, angle, side. Congruency. AAS. And number 8, as a result of the triangle being congruent, AH is equal to BG CPCTC, corresponding parts of congruent triangles congruent. And that ends up ends the unit, or sorry, ends the video on using the properties of a parallelogram, using the opposite sides parallel. And there's more proofs to come related to the parallelogram. And if you like my video, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.